Guys, this is Megavashmi Saravanan. So, in this session, we are going to learn a tidbits about the plant biotechnology, especially the contents from the DNA. Okay, so the first and foremost question is that what links the opposite strands of a DNA? So, the opposite strands, that is, the sugar phosphate complexes, are linked or joined together by the hydrogen bonds because the complexes have the attachment of the bases, and these bases are attached together by the hydrogen bonds. So this is an important half mark question which is asked in your mid semester examination. Phosphodiester bond. Phosphodiester bond is usually directed from the 5 dash to the 3 dash end. That is, the 5 dash phosphate group is attached to the 3 dash carbon. 3, that is the hydroxide group of the 3 dash carbon. So they are formed by the process of condensation. That is the removal of water, and this phosphodiester bond is the bond which is existing between the two nucleotides. Okay, the two nucleotides are joined by the phosphodiester bond. Okay, and what is meant by exons? Exons are expressive sequences or the coding sequences. So these are represented by the matured mRNA. mRNA is nothing but the messenger RNA. So introns are the non-coding sequences. They don't have any representation of the mRNA. Okay, so splicing, this is a very important one mark question which can be asked in your definition at your semester examinations. Okay, so splicing is nothing but removal of introns, that is a non-coding sequences. Okay, and UTR, untranslated region is nothing but the 3 dash and the 5 dash ends. So this 3 dash and the 5 dash ends would usually have the gene regulation. That is, they regulate the genes expressions. Okay, for example, the half-life of the mRNA. Okay, so the backbone of DNA, this can be asked in your half mark question and in your competitive examinations. Dash turns to be the backbone of DNA. The backbone of DNA is nucleotide. This nucleotide consists of the three essential things. They are, first one is that pentose sugar, nitrogenous base, and the phosphate group. Okay, histones are nothing but the proteins. Proteins are usually alkaline in nature. So this histone proteins forms the protein core on which the DNA is wounded. Okay, non-histones are nucleic acid, acidic nuclear proteins. They are acidic because they contains the amino acid. Okay, and packing ratio, this packing ratio is very important. See, cell is a microscopic minute structure. How this cell contains a lengthy and long DNA in its nucleus. Cell is usually a small structure. Of course, nucleus will be very tiny. So how this lengthy and long DNA is comprised or condensed in the nucleus, this is because of the packing ratio. So the packing ratio can be calculated by the formula, the length of the DNA to the length of the package. For example, if the length of the DNA is 16,000 mu meter and it is packed at 4 mu meter, it is an example. Okay, so what turns to be the packing ratio? So 16,000 mu meter divided by 4 mu meter, which gives 4,000. That is, the packing ratio is 4,000. Okay, so with this I would like to end up this session. I want to give you a question to work out, that is, calculate the packing ratio of the DNA of length 14,000 mu meter and the package length of 2 mu meter. Hope that you all guys would solve this question and give me the answer in the comment section. So always stay tuned. Bye guys.